One possible effect of the enhanced greenhouse effect is a rise of mean sea level. An increase in temperature, as stated before, could cause more ice and snow to melt, causing an increased volume in seas and oceans. Using climate models, predictions say in the next 100 years, surface temperature will increase by 1.5 to 4.5 degrees Celsius. The sea level will increase 50 to 65 centimeters. Measurements and expectations cannot be exact though, because of the irregular expansion of water in different temperature zones. Different evaporation rates between warm seas and cold seas. Ice melting in the water and ice melting on the land affects this differently also. Now that you understand how this greenhouse effect makes the sea level change, I'm going to be talking about melting ice. I just talked about it, but with an increase in temperature, the sea and land ice will melt and do different things to the environment. Each melts in its own unique way. Sea ice freezes and melts due to a combination of factors, including the age of the ice, air temperatures, and solar insolation. During the winter, the area of the Arctic Ocean covered by the sea ice increases, usually reaching a maximum extent during the month of March. The area covered in sea ice then decreases, reaching its maximum extent in September most years. First-year ice melts more easily than older ice for two reasons. First-year ice is thinner than old ice. Since the process of congelation, growth has had less time to operate. First-year ice is also less permeable than older ice, so summer meltwater tends to form deeper ponds on the first-year ice. Deeper ponds mean lower albedo and thus greater solar energy capture. The loss of sea ice initiates a feedback loop known as Arctic amplification. As sea ice melts, it exposes darker ocean waters to incoming solar radiation. The ocean then absorbs far more energy than it has been in the case when brightly colored sea ice was present, and this increases water and air temperatures, thereby melting even more sea ice. Peter Wadhams, the head of Polar Ocean Physics Group at the University of Cambridge in the UK, told BBC News on September 6th that adding heat from sea ice loss is equivalent to warming from 20 years of carbon dioxide emissions. Carbon dioxide is the main greenhouse gas that is causing man-made global warming. Skeptic arguments that Antarctica is gaining ice frequently hinge on an error of omission, namely ignoring the difference between land ice and sea ice. In glaciology, and particularly with respect to Antarctic ice, not all things are created equal. Let us consider the following differences. Antarctic land ice is the ice which has accumulated over thousands of years on the Antarctic landmass itself through snowfall. This land ice, therefore, is actually stored ocean water that once fell as precipitation. Sea ice in Antarctica is quite different, as it is generally considered to be ice which forms in salt water, primarily during the winter months. In Antarctica, sea ice grows quite extensively during winter, but nearly completely melts away during the summer. That is where the important difference between Antarctic and Arctic sea ice exists. Arctic sea ice lasts all year round. There are increases during the winter months and decreases during the summer months, but an ice cover does in fact remain in the north, which includes quite a bit of ice from previous years. Essentially, Arctic ice is more important for the Earth's energy balance because, when it melts, more sunlight is absorbed by the oceans, whereas Antarctic ice normally melts each summer, leaving Earth's energy balance largely unchanged. This directly affects climate change. When solar radiation causes temperature to increase, wind current flow patterns and other seasonal events will occur more often.